All right, we're in section 2.6 of Al Grosch's book, Developmental Math 2. We're going to talk about solving inequalities today. The basic premise for solving inequalities is the same as solving equations. We're going to isolate inequalities, which look the same as equations. We're going to isolate them for x. The only difference being now we have to think about these symbols instead of the equal sign. We have the less than, the greater than, the less than or equal, and the greater than or equal. The only difference between these, of course, is the equal symbol has the equal bar under the less than, greater than. So when you see that symbol, you have to think about your solution being inclusive. The notation on a line graph, such as down here, has an open circle or a closed circle. The open circle is used with the less than and greater than. The closed circle is used when we have the equal to quality, the equal to bar. The parentheses in interval notation are used with the less than, greater than. The brackets when we have the equal to. Also, it is possible that you could use the parentheses and brackets on the number graph. We have seen that, and you might see it in homework. When you have the open circle, it's okay to use parentheses instead of the open circle. With the closed circle, it's okay to use brackets. So you could see it either way on a line graph. All right, so let's look at this example. It says graph, -2 is less than x is less than or equal to 3. So this is read as x is greater than -2 and s is less than or equal to 3. So use the line graph. If x is less than or equal to 3, then the equal to means the closed circle or the brackets. These are the values less than, so they're shaded. Less than 3 is shaded here with the closed circle at 3 because the equal to on the less than symbol. -2 is less than x is the same as x is greater than -2. Those are the same. You can turn it around this way. It's easier to read if you write the variable first. So when you flip the order of these like this, the symbol switches from less than to greater than. So x is greater than -2. There's no equal on the -2, so that's why the open circle or the parentheses and then shaded this way. And of course, the two bits of shading, they meet in the middle. So what we're saying is the values that are acceptable for x have to be greater than -2. At the same time, they have to be less than or equal to 3. So this shading indicates where all the values are greater than -2 and less than or equal to 3. Using interval notation, and you can see the interval notation right here. Interval notation is basically just really a snapshot of what your graph is shaded, the shading section of your graph. We read them left to right. So for interval notation, you start with the left boundary of your graph, and it is a parentheses because the -2 is open. There's no equal sign at the -2. Then a comma, and then the right boundary of your graph, the right boundary of your shading is here at +3, and it has a closed circle because of the equal to that's on the 3 up here. So this is what we call the interval notation. It's not an ordered pair. It's not a point, so don't get it confused with that. It's just a shorthand for your graph, for writing your graph. It's telling you where all the values of x are shaded on your graph. So we're going to practice on this page, first graphing with a line graph and then using interval notation. So the statement says x is less than or equal to -3. So we're going to start by making a line, a number line. It doesn't have to be hugely detailed. It should have 0 and the -3 marked because the -3 is the important number. And then we're going to use a closed circle at -3 because this has an equal to bar on it. So we know the -3 has to be closed. You can also use brackets. Okay, they mean the same thing. We wouldn't usually use both, but I'm going to put them both on there so you guys can see. And now we have to decide which way we're going to shade. X is less than -3. That's what this says. So all the values that are less than -3 need to be shaded. So we're going to do some shading here. We're going to shade this way, and of course, it doesn't tell us where to stop, so those values go off into -infinity. So that's what the number line looks like. For the interval notation, we're looking at where's the shading. It's a snapshot of the shorthand of the shading. The left boundary of the shading is negative infinity. And infinity symbols always use parentheses. They're never closed, so they don't get brackets. The right boundary of the shading is negative 3. And the negative 3 is closed because of that equal sign, so it has a bracket. And that's the interval notation. For example 2, we're going to graph two different statements on the same graph. X is greater than 3 or X is less than 1. So that means there's two different places where X could be. So starting with our graph, we're going to mark 0, and this is 1, and this is 3, and of course there are some other points out there. The first statement says X is greater than 3. So it doesn't have the equal. So that's telling us that the 3 is open. Could be an open circle, or it could be parentheses. X is greater than 3 means we're going to shade the values greater than 3. And it doesn't tell us any place to stop, so we're going on to infinity. This other statement says X is less than 1. So again, it's open because there's no equal to. And the values less than 1 are here. And they go off into negative infinity. So there are two pieces of shading on this graph, and that's caused by this or statement here, making two different qualifications for X and saying or leaves you with two chunks of shading. So now to do interval notation is a little bit more complicated because we have to have an interval for each piece of shading. So we're going to have two different intervals, and we'll join them with the union sign that we learned previously. So this first piece of shading, the left boundary is negative infinity. And of course, negative infinity always gets parentheses because it's never closed. And the right boundary is 1, again with parentheses because there's no equal sign. And then this shading has open 3 for the left boundary, parentheses on infinity for the right boundary. When we have two chunks of shading, we join them with a U for union. So when you have each piece of shading has to have its own interval and then join with U. If for some reason we had another piece of shading, we'd have to write a third interval and we'd join it with U. All right, so for question 3, we have negative 1 is less than or equal to X, which is less than 7. So this is more like an and statement, but the and is implied by putting it all in one statement here. So starting with a line graph, this is 0, negative 1, and 7. So the important points are negative 1 and 7. You can see by the statement here, this less than or equal to on the negative 1 is closed. So we're going to either color it in or we're going to use a bracket. The 7, however, does not have the equal to, so it's going to get a parentheses. And those are important. I like them on the number line, although sometimes you will see the closed and open circles. You don't have to put them both on, one or the other. I'm using them both so that you guys make the connections. All right, now this is telling us that X is less than 7. So I like to read this part first. It tells me that I need to shade less than 7. So that's starting here. But the other piece of this says that X is greater than negative 1 because negative 1 is less than X. And again, you can reverse the order of this and say X is greater than or equal to negative 1. You can reverse the order, so that would be telling you that there's shading here, and the two shadings meet in the middle. And then your interval notation is going to have a bracket, negative 1 for the left boundary, 7 for the right boundary, and a parentheses. So up at the top of the next page, we have an example for solving an inequality. On the last page, the last two pages, all the inequalities were already solved for X. X is less than 1 or X is greater than 7. This example here is not solved for X, but we're being asked to verify, is 10 a solution for this? And just like regular equations, we're just going to substitute the 10 right in there and simplify. So 2 times 10 minus 5 greater than 7. And we're trying to find out if that's a true statement. 2 times 10 is 20. 20 minus 5 is 15. Is 15 greater than 7? Yes, it is. So is this a solution? Yes, it is. Remember, and this is an important thing right here, if you multiply or divide both sides by negative, then the inequality changes direction. In other words, while you're solving or trying to isolate for x, while you're doing opposite operations, if you have to multiply or divide by a negative, then you have to change less than to greater than or greater than to less than. The inequality symbol will change directions. And we're going to practice that down the page here. Okay, so let's solve. Here's the statement. 2x minus 5 greater than 7. So let's write that right here. All right, to isolate this x, we have to first add 5 to both sides. So this is just like an equation, except for that one extra rule that we just talked about up here, multiplying or dividing by a negative. So this gives us 2x greater than 12, and then divide by 2. Now this is where it would happen if we divide by a negative here. This is where we have to change the direction of the symbol, but this is not a negative, so we don't have to worry about changing direction. So we just end up having x is greater than 6. And of course we could graph that on a number line like we did before and write interval notation. We don't really have room to do that. We're going to do it down here. Let's try this one. Solve for x. Negative 3x plus 2 is greater than 23. So I'm going to start by writing it over. Negative 3x plus 2 is greater than 23. First thing we need to do is subtract 2. And we have negative 3x is greater than 21. And then we have to divide by negative 3. Now this is what we're talking about. If you divide by a negative like this, you have to flip the direction of the inequality symbol. So this is now going to change to less than. Now, once you do that, it doesn't affect what happens with the numbers. This still becomes positive 1x, and this still becomes, well, this should be a negative 3, shouldn't it? Negative 7 over here. So just to review, if you divide, and you will do both sides, if you divide by a negative, and it happens when you're trying to get the coefficient off the x, if you divide or multiply by a negative, you have to flip the direction of the symbol. So greater than became less than, and we ended up with x is less than negative 7. So let's look at these examples. We're going to solve. We're going to start by writing 10 minus 2x is greater than 15. The first thing we need to do is subtract this 10, trying to isolate this x right here. So subtract 10 from both sides. Now subtraction doesn't affect the inequality symbol, so you don't have to worry about flipping the sign. And then to isolate this x, divide by negative 2. This is what I'm talking about. Here you divided by a negative, so you have to flip this. This is not greater than anymore. It's less than. These reduce to make x, and of course this over here, you don't need to change it to mixed. As long as it's reduced, you're fine. So x is less than negative 5/2. So we're going to solve for x here. I'm going to rewrite 6x minus 8 is less than or equal to 8x plus 10. All right, it looks like the first thing I really need to do is put both these x terms on the same side. And these are easiest to read if you always do put x on the left. It's okay to put x on the right, but if you're choosing your answer from multiple choice or you're drawing a graph, it's just easiest to read if you put x on the left. So I'm going to subtract 8x to start with. I'm going to line that up under the like terms, the 6x. It cancels off of here. So now I have negative 2x minus 8 is less than or equal to 10. Still trying to isolate this x, so now I've got to add the 8 to both sides. So negative 2x is less than or equal to 18. And now, to get rid of this negative 2, divide, and this is it again. When you divide by a negative, your symbol flips, and it's not less than or equal to anymore, it's greater than or equal to. This is x, and this is negative 9. So x is greater than or equal to negative 9. All right, on this one, this is pretty complex here because we're going to have to do some distributive property and combining like terms just to get this equation in a good form. So I'm going to rewrite 8 times y plus 1 greater than or equal to 2 times y minus 4 plus y. So the first thing we're going to do is distribute to get rid of these parentheses. So that's 8 times y plus 8 times 1 greater than or equal to 2 times y minus 2 times 4 plus this other y down here. And you can see here on the right there are like terms that need to be combined. So we still have 8y plus 8 greater than or equal to, okay, 2y plus 1 is 3y minus 8. Once we get it that far, we should put all the y's on the left. So I'm going to subtract 3y. And that gives me 5y plus 8 greater than or equal to negative 8. All right, trying to isolate this y, subtracting 8. So 5y greater than or equal to negative 16. And the last step, divide by 5. Now this time we didn't divide by a negative, we divided by positive 5, so we don't need to flip the symbol. So we have y greater than or equal to negative 16 over 5. All right, on the next page we have what's called compound inequalities. These are called compound inequalities because they have more than one symbol. You see, we did one of these in a previous example. This is like saying and. Negative 5 is less than or equal to x plus 4, and it also has to be less than or equal to 6. So all the values of x have to meet both of these parameters at the same time. Now, the x is not isolated here, so we have to worry about getting this to say just x in the middle. So what we're going to do is we're going to, first of all, rewrite it. Negative 5 less than or equal to x plus 4 less than or equal to 6. We're going to use some vertical lines where the less than equal to symbols are. And now everything that we do in the middle here to isolate this x, we're going to undo this. We also have to do on the right and on the left. So it's the same idea, except now you have 3 places that you have to balance out. So we need to subtract this 4. So we're going to subtract 4 on the right and on the left. And that's going to leave us with just x by itself in the middle. Of course, we didn't multiply or divide by a negative, so we don't have to worry about the symbols flipping. And we're just going to simplify. 6 minus 4 makes 2. And negative 5 minus 4 makes negative 9. So negative 9 is less than or equal to x, which is less than or equal to 2. I would like to go ahead and make a number line for this so that we could practice that again. And maybe some interval notation also. So there's our number line. So we'll say this is negative 9. Okay. So this will be 0. And this will be positive 2. So those are the important numbers, negative 9 and positive 2. And they're both closed because we have the equal to. So we should color them both in, or we could use brackets if we wanted to. And we're going to shade. I'm going to start with the x is less than or equal to 2. So I'm going to shade this part first. Less than 2 goes this way. And then when I read this, it's x is greater than negative 9. So that goes this way. And there's the shading right there. Then the interval, left boundary is closed at negative 9. Right boundary is also closed at 2. So that's the interval notation for that. So let's do number 2. Similar type of question. We're going to start by rewriting the question. Negative 12 is less than 2x minus 6 is less than 16. We are going to isolate x in the middle here. So I'm going to use the vertical lines again, where I have the less than or equal, the less than or greater than symbols. And I'm just going to undo these operations, starting with the negative 6. So add 6 on the right and on the left. That gives us a 2x in the middle, still less than 16 plus 6 on the right is 22. Negative 12 plus 6 on the left is 6. Negative 6. Now we're going to divide by 2 to isolate that x. And again, we're dividing by a positive 2, so we don't have to worry about the symbols flipping. This becomes x. This becomes 11. This becomes negative 3. So negative 3 is less than x, it's less than 11, and we're going to make a number line for this again. So let's start with negative 3 here, and that means this will be 0, and this will be 11. And negative 3 and 11 are the important numbers. Now this time they're going to be open because there's no equal bar under here. So we could leave them as open circles, or they could be parentheses, which mean the same. Now to the shading, x is less than 11. So shade less than 11. X is greater than negative 3. So shade negative 3. The interval, open for the left boundary at negative 3. Right boundary, open at 11. All right, for number 3, we're going to need to simplify first to get rid of these parentheses. So I'm going to rewrite negative 11 less than or equal to 3 times 7 minus x less than 8. So let's simplify this stuff in the middle first. Negative 11 less than or equal to, this is distribute, 3 times 7 is 21. 3 times negative x is negative 3x and less than 8. And now I'm going to put my vertical lines in just to separate things. All right, to isolate this x in the middle here, we first need to get rid of, this is a positive 21, so we're going to subtract 21. On the right also, and on the left. All right, subtraction doesn't affect our inequality symbols, but we now have negative 3x here in the middle. 8 minus 21 is negative 13. Negative 11 minus 21 is negative 32. Now to isolate this x, we're going to have to divide by negative 3. So that cancels to give us just x in the middle. Oh, I made a mistake there. Because we divided by a negative, remember, when you divide by a negative, you have to flip the direction of these symbols. So these are now greater than. This, of course, a negative divided by a negative makes a positive. So this would be positive 13 over 3. And over here, negative divided by negative makes positive again, 32 over 3. Of course, you would want to simplify those fractions if they could be simplified. The one thing I do want to say is this is not the traditional way to write a solution for a compound inequality. The traditional way has less than symbols. Okay, so there's a little trick here just to turn them back into less than symbols. All you have to do is flip these two numbers, because this is really saying x is greater than 13 over 3 and x is less than 32 over 2. So if you flip these two numbers, the symbols can go back to being less than. So that's what I'm going to do here. I'm going to put 13 over 3 on the left, less than x, less than 32 over 2. And this is a more traditional way, except this one has an equal on it. This is a more traditional way to write this statement with the less than symbols instead of with the greater than symbols.